Between the land requirements, the grid constraints, and the thermal penalty, Earth's infrastructure is physically choking the hardware. Scaling intelligence exponentially on the ground is mathematically difficult over the long term. To bypass these physical limits, Elon Musk has initiated a $20 billion hardware insurance policy. It is a joint venture between Tesla, SpaceX, and xAI, known as the terafab project. The target scale for this facility in Texas is roughly 100 million square feet. To put that physical footprint in perspective, it is large enough to consume the entire sovereign states of Vatican City and Monaco combined. The core mechanism driving terafab is extreme vertical integration, a manufacturing strategy where a company controls every step of production. Inside this one facility, engineers will design the lithography masks, print the memory, fabricate the silicon, and test the final chips. Consolidating the entire supply chain under one roof creates a 9-month recursive improvement cycle. Engineers can test a chip, identify hardware flaws, redesign the mask, and print a new iteration without ever leaving the building, targeting an eventual output of 1 million wafer starts per month. Compare that to the fragmented global supply chain, where a chip is designed in California, printed in Taiwan, and shipped to Malaysia for packaging. At full capacity, this single Texas campus intends to match 70% of TSMC's total global output. By pulling the entire silicon supply chain in-house, terafab creates an extreme physical hedge designed to bypass global bottlenecks. Currently, a staggering 80% of the massive compute output generated by terafab is destined directly for Earth orbit. The facility will mass-produce the D3 chip. This is a high-power, radiation-hardened processor built explicitly to survive and operate in the harsh vacuum of space. Moving the digital economy off-planet requires heavy logistics. SpaceX's Starship rocket is designed to carry 100 tons of payload per flight, providing the lift capacity necessary to deploy a planned constellation of 1 million AI satellites. Space solves both terrestrial energy and cooling bottlenecks. Sun-synchronous orbits keep satellites in continuous sunlight, capturing energy 5 times stronger than on Earth. Without air conditioning, massive space radiators achieve near-infinite heat rejection directly into the void. Ultimately, moving these massive data centers to orbit transforms Earth's strict physical limits from a dead end into a launch pad. As launch costs continue to fall, economic models project that the cost of space-based AI compute will drop below terrestrial costs in just 2 to 3 years. The terafab protocol is targeting an annual output of 1 terawatt of compute. To understand that scale, the entire global chip industry combined currently produces roughly 20 gigawatts. Terafab plans to outpace the planet by a factor of 50. To reach the next order of magnitude, Tesla plans to use humanoid robots to build an electromagnetic mass driver on the moon. A mass driver is an electrically powered catapult used to accelerate and launch payloads without the need for chemical rockets. Because the moon has 1/6 of Earth's gravity and no atmosphere, a mass driver drops the cost of launching hardware into deep space down to the bare price of electricity. This opens the door to petawatt-scale compute, 1,000 times larger than the terafab target. Capturing 1/millionth of the sun's energy via lunar manufacturing and orbital swarms moves humanity toward a Kardashev Type 1 civilization, a society capable of utilizing the total energy reaching its home planet. In this scenario, high-level reasoning can be scaled and deployed as a cheap, standard utility. The race to artificial general intelligence is a physical competition. The entity that owns the physical supply chain, the atoms, the manufacturing, and the energy, dictates the pace of progress. Terafab represents a closed loop. It is a deliberate strategy to decouple global economic progress from fragile terrestrial choke points. True future wealth lies in sovereign physical infrastructure. If you want to understand the exact mechanisms driving this hardware revolution, make sure to subscribe, and we'll see you in the next video.